Hello Abaqus user. Welcome to Abaqus Acumen for quick and sound learning. Today's session we are going to do on a bending of strip, and then we'll first try to bend it and then try to roll it, and then we'll roll it. So the whole purpose of this video is to demonstrate the 2D contact within Abaqus, and it's very straightforward example. So we'll try to solve this example, and just to quickly we will go to the drawing board and understand how we are going to do this. So we are going to do like not specific example here, but try to demonstrate how we can do a 2D contact example in Abaqus Explicit. And like all are rigid, all these are rigid. This is only deformable, which is like 2 millimeter by 400 millimeter, and this is what plasticity detail. So setting up an example is very easy and straightforward. The only thing is how you can demonstrate something like this. So you get good contact here, do the bending and in one step, and then start rolling it, and then you roll it. So let's quickly start it. So I'll first create 2D planar discrete element. This will I keep 100, and I'll say rigid 1. So I'll keep 0, 0, and then I'll define this like 25. So we define that, we'll quickly have so done, and then we'll have property tool reference point. So we given a reference point. Let's copy it and make 2 more rigid of same size 2, and then we copy it and then same size will make rigid 3. So we created 3 rigids, 2 and 3. We'll create one planar shell. Quickly we'll so we define the workpiece. We'll define the property for that. A typical steel property 7.85 e power minus 9. Elasticity data 7.85 e power minus 9. Sorry, 210 e power 03.3. We define density, we define this, we'll have plasticity data 120, 0, 240, 0.6. Then we'll define the material property. Now we'll quickly define. So now we'll position it. First I'll just make rigid 2 and 3 move down by minus 52, so that way they come down. Then I move 2 by 40, 0, -40 comma 0, and then we'll move this zero comma 25, and then we'll move this by 35 millimeter, 35,0. So we position now the workpiece in proper in two roller. Now we'll bring it down this by 18 millimeter, and then we'll start rolling it. So let's first create the step, which will be bending step. Which will be dynamic explicit step. This is time in second, and then we will define the interactions. Will define first normal behavior soft, then we'll define the penalty based friction of 0.3, yellow. Then I'll select the surface. We define the first contact, then I'm defining surface to surface second contact. I'll select this, and then yellow, I'll select the surface, and selected that yellow. So we define the contact. Now we'll quickly put a mesh. We'll create one more. We created the step. We'll define the boundary condition. So my first thing is this will come down. This will come by -18, and let me put a tabular like 0 0 0.3751. So moving down by that, and then second boundary condition is end caster condition. So we define that. Now we'll have second step, which will be bending step, rolling step. So it will be like 1. Now let me first go and deactivate both the boundary condition in second step, and then we'll create. Now I'm just rotating it. So if I have to move this by positive theta z direction, then you keep your thumb in z direction and rotate your finger around that, so that is your positive z direction. So I'll create that, rolling. So second, and then bottom one will rotate about the negative. -6.28. So we define that. Let me put mesh for this is like chord middle axis theorem. This will be like 2 millimeter. I'll select right plane strain condition, and then just mesh it. So this is good enough mesh. I'll mesh rigid one with 2 millimeter again, and then we'll select also the right. Then I'll put rigid 3. So we define all the 3, so you can see in mesh. Now let me save this file, contact explicit 2D. So let me put a data check first. So let's see the data check how. If everything is fine, then we'll just go ahead and submit the run. So we just put a data check. So there is no issue related to preprocessor. So looks like everything is fine. So let's submit the run, and then we'll just wait how the results looks like. So I just submitted a run, and then we'll just check. So we just finished the first step. So you can see how the 2D contact take place, and how so you can really plot different things. Like we can also plot something like a contact pressure also. By the time the second step is going on, rolling, the contact pressure are there, but it is on line. So let me first check the stress component, one mice stress component. It is not gone in very plasticity anything, but we'll just wait till that it have. So we get a good bending now. We have done a bending, and then we hope to do a rolling part now. So it's rolling. It just started, so it bent and then it started rolling. So you can submit a run and wait how it get roll, but you can see now the rolling start. So this is a good to have rolling and bending, just to demonstrate how we can do lot of things using Abaqus Explicit, like a 2D contact and rolling of strip. So this was a quick video for you. Couple of things you can do with is like you can exclude it in third direction, and you can also make 2D problem like 3D. So you can go for a free edge, and then you can, so if you put here in, and then you can see a rolling, how the rolling take place. So the bending and then rolling. So this is a good demonstrating video of this contact example. Go ahead, and if you like this video, don't forget to like us and subscribe us. Thank you for watching this video. Thank you. Bye bye.